Hello everyone. In this video I'll be discussing about the Leetcode problem 101 symmetric tree. Given the root of a binary tree, check whether it is a mirror of itself, that is symmetric around its center. So it basically says that given a binary tree, if you put a mirror just below the root and and can you superimpose the left image on top of the right mirror view? If you can, then it's a symmetric tree. Like here, if you put a mirror here and you then like just like you flip a page of a book, if you flip the left side on top of the right side, do the nodes overlap each other exactly? If yes, then it's a symmetric tree. So this does, because 4 is same as 4, 2 is 2, 3 is same as this 3. But here if you see the second example, if you put a mirror here, 2 will overlap 2, but 3 will not overlap 3, because it will like if you turn it this way, it will become, it won't overlap. These two nodes will not overlap each other. So that is the question. So in order to solve this problem, we are given we are given the root of this tree. Now what we need to do is, first we need to check the root. If root is null, then it is by default symmetric, right? So that is the first case. Second case is, if root is not null, then you get a left subtree and a right subtree of a non-null root. Now, as I mentioned earlier, we need to put a mirror below the root and then check whether the left subtree overlaps is a mirror image of the right subtree, right? So basically what we will do is, we will write a recursive method to check whether the left subtree is a mirror of right subtree. Okay, and if that returns true, then the overall tree is symmetric. So let us first write the null check. So we'll say if root is equal to null, that means it is symmetric, so we return true. If not, then we return, we call a recursive function is mirror, okay, and then pass the root dot left and root dot right, both parameters, and then return whatever it returns. So we need to create a method which will return boolean. It's called is mirror, and it takes two parameters, tree node left and tree node right. Okay, and now what we will check is, see here, in here this is the this is the left subtree and this is the right subtree. We check the root nodes of both the trees, and if they are same, then we proceed ahead. So first check is, so first let's add the null check. If left dot val is equal to null, and if right dot val is equal to null, if both of them are null, then you return true. Okay, else if root dot left is equal to null and root dot right is equal to null, here is an or. If any of them is null but not both, then you return false. Else what you do is, if So you basically, what you need to do is you return root dot val is equal to, so left dot val is equal to right dot val, and another if condition, recursively call this is. So now what do we want to check? So we have checked here that if left dot val is equal to right dot val, if this root and the right subtree's root is same, then we need to check is mirror on this node and this node. So base and the second version would be this node and this node. So we are assuming there is subtree below these nodes also. Now how do we make sure do the check here? We check for, say this is the left in this call and this is the right. We say left dot right and right dot left. So we say left dot right and right dot left are they mirror? And the third check is mirror of now this subtree and this subtree. So this is left of left and right's right. So left of left and right's right. Okay, and basically this entirely is an if condition. It will return true. So these are three statements. If that is if the root of the left subtree and right subtree they matches, and if the right side of the left and the left side of the right is mirror, and if the left of the left and the right part of the right is mirror again, that means it's a complete symmetric tree, right? So let us see if that works. Okay, what happened? Okay, I should have just used without val. Okay. Okay, there is no root here, so I should have said left and right only. I got confused with the keyword root. Okay, so both cases succeed, and yeah, I hope this was useful to you, and yes, all right, thank you.